All right. Today we're going to take a look at polynomial long division. In the previous video, you should have looked at a math is fun kind of animation, just introducing you to this idea of of dividing with polynomial long division. So now we're going to take a look at actual dividing. So we're going to take a look at a few number examples. Then after we go through and do the number examples, I'll add the polynomials back into the problem. So let's get started. The first one that we're going to do is 324 divided by 27. So I'm going to set it up so that it looks like this. 27 goes on the outside, that's your divisor. 324 goes on the inside, that's your dividend. And we're going to be looking for the answer, which is the quotient. So that's what we're going to be looking for. So way back when Mr. or Mrs. somebody taught you about doing dividing with numbers. So before we started doing calculators and things like that, we did long division with numbers. So let's recap that concept. So you will see 27 goes into 3 how many times? Since 27 does not go into 3, we skip that and now we move on to 32. So 27 goes into 32 how many times? It goes into 32 once. And you put your answer up there at the top. Now we multiply. 1 times 27 is 27. Draw the line, subtract. 32 minus 27 is 5. We haven't touched the 4, bring the 4 down. And you repeat the process. 27 goes into 54 how many times? Twice. Now we multiply. 2 times 27 is 54. Draw the line, subtract. 54 minus 54 is 0. Just out of habit, way back when, since I've been doing long division, I always just circle my remainder so that I could kind of keep track with if I have anything left over. So in this particular example, I do not have anything left over. My remainder is 0. So that means that 27 and 12 are both factors of 324. So 27 is a factor. And I know that 27 is a factor because it goes into 324 evenly. So 27 is a factor because there's no remainder. So this may be a good thing, actually a great thing for you to do because dividing is going to help us find factors and roots from graphing in a few days. So we'll be tying some stuff together. So you should know that if you do not have a remainder, that means that the divisor is a factor. So in this particular example, 27 is a factor of 324. Now let's take a look at number 2. We're going to set it up and we're going to do some long division. Okay. 7 goes into 9 how many times? Once. So we're going to put a 1 at the top. Now we're going to multiply. 1 times 7 is 7. Draw your line. Subtract. 9 minus 7 is 2. And you bring the first one straight down. Repeat the process. 7 goes into 21 how many times? 3 times. So I put 3 at the top. Multiply. 3 times 7 is 21. Draw the line. Subtract. Gives me 0. This one comes straight down. 7 goes into 1 how many times? It doesn't, so we put a 0 at the top. 0 times 7 is 0. Draw the line, subtract. 1 minus 0 is 1. So sometimes it works out evenly, like the first example we did, and other times you'll get a remainder. In this particular case, for problem number 2, we got a remainder. So our answer will be 130 remainder 1. And you write your remainder over your divisor. So 130, 1 is the remainder, 7 is the divisor. So I wrote 1 over 7. So that's how you will write your answer. And this also means that 7 is not a factor. So 7 is not a factor. And how do I know it's not a factor? Because we got a remainder of 1. And to be a factor, it has to work out evenly. So no different than if I asked you to list factors of 12. You wouldn't tell me 5 was a factor of 12 because it doesn't work out evenly. It's not evenly divisible. So same case if I'm working with numbers and in a minute or so polynomials. So this was a recap of doing long division with just numbers. Hopefully it came back to you. Take whatever's on the outside, see how many times it goes to the inside, and then it's repetition of multiply, subtract. Sometimes it'll be a factor if you get 0, and then other times it will not be a factor. Now let's get into some actual polynomials and bring this back into Math 3 world. All right, so the first one we're going to take a look at is x squared plus 7x minus 30, and we're going to divide that by x minus 3. So let's set up the problem like we're supposed to. So I'm going to put x minus 3 here, and then x squared plus 7x minus 30. All right. So now you can see how many times the term on the outside, the first term on the outside, goes into the first term on the inside. So you have two ways of thinking about this. So you can think of it as x times what gives me x squared. So x times something gives me x squared. Or you can think of it as x squared divided by x gives you what? X squared divided by x gives us this something that we're missing. Either way, x is the term that we're missing. So personally, I think of it in terms of multiplication. So I ask myself, x times what gives you x squared? And that something that we're missing was x. So that goes up there at the top. Now we multiply. X times x gives me x squared. X times negative 3 gives me negative 3x. Draw the line, subtract. Make sure you put subtraction out there to the side so that you do not get the wrong sign. So that is probably the most common mistake that I see students make, is that you don't put the subtraction out there and you subtract incorrectly, or you add, but this is subtracting. X squared minus x squared goes away, gives us 0. 7x minus negative 3x gives us 10x. Bring down the negative 30. I haven't touched it. Bring it down. Now repeat the process. X times something gives me 10x. So x times something gives me 10x. That something that we're missing is a positive 10. So I put that up there at the top. Now we multiply. Whatever's on top, multiply by everything that's on the outside. 10 times x is 10x. 10 times negative 3 is negative 30. Draw the line, subtract. 10x minus 10x goes away. It gives us 0. Negative 30 minus negative 30 cancels out as well. Gives us 0. So this tells us a number of things. It tells us first that x minus 3 is a factor. X minus 3 is a factor. And I know that because I got a remainder of 0. There is no remainder. There's nothing left over. So it tells me x minus 3 is a factor. And it also tells me the quotient, which is the answer. So the answer to this problem is x plus 10. So x squared plus 7x minus 30 divided by x minus 3 is x plus 10. That's my answer. Same thing that I did up here with the numbers. How many times does this go into this, etc., multiply, subtract, except for now we do have variables and exponents and things like that, but we're still doing long division. Let's definitely try some more. So and I'll try to leave that in the viewing screen for us there so we can take a look there. Okay, so let's take a look at number 2. This time I'm doing a squared plus 7a minus 11 divided by a plus 5. So let's set it up. So when I set it up, we know that x plus 5 goes on the outside. That is our divisor. And a squared plus 7a minus 11 goes on the inside. Now, when you set this up, you want to make sure there's a number for everything. So you want to make sure it goes from the biggest exponent all the way down to the smallest one. So x squared, a squared, a to the first power, and then my number. So say it jumped from a squared to the number, then I would need to put a placeholder here. But that's coming up in, if not the next example, it's the one after that. So I'll show you about what a placeholder is. Okay, let's get started. A times something gives me a squared. First term on the outside, first term on the inside. See what it takes to get there. So a times what gives you a squared? That's going to be a. A times a is a squared. A times 5 is 5a. Draw the line and subtract. A squared minus a squared goes away, cancels. 7a minus 5a gives us 2a. And bring this minus 11 down because we haven't touched it. Repeat the pattern. A times what gives you 2a? So a times what gives you 2a? That's something that we're missing is 2. So 2 goes up there at the top. Multiply. Whatever's on the top, you multiply by however many terms are on the outside. 2 times a is 2a. 2 times 5 is 10. Draw the line, subtract. 2a minus 2a cancels out. You're left with 0. Negative 11 minus 10 gives me negative 21. Be careful with your signs. That's negative 11 minus 10. That gives you negative 21. So for this particular example, a plus 5 is not a factor. A plus 5 is not a factor. And our quotient, which is our answer, is a plus 2. Take your remainder, which is negative 21, and write it over our divisor, which is a plus 5. So take your remainder, which is negative 21, write it over your divisor, which is on the outside. So our answer is a plus 2 minus 21 over a plus 5. So the first one that we took a look at, our divisor was a factor because we did not get a remainder. The second one that we take a look at is not a factor because I do have a remainder. All right, let's definitely take a look at some more. Sometimes this is a kind of a harder concept for students to understand. So let's go through another one. All right, number 3. 2x to the third plus 3x squared minus 4x plus 15. And we're going to divide it by x plus 3. So I've already set this problem up. So now we'll just go through and work it out. Take the first term on the outside. See how many times it goes into the first term on the inside. So x times what gives me 2x to the third. So x times what gives me 2x to the third. That's something that we're missing is 2x squared. Now multiply. Whatever's on top, multiply it to however many terms are on the outside. Whether it's 2 terms, 3 terms, 4 terms, you multiply it by whatever's on the outside. 2x squared times x is 2x to the third. 2x squared times 3 is 6x squared. Draw the line and subtract. 2x to the third minus 2x to the third goes away. 3x squared minus 6x squared is negative 3x squared. We haven't touched these two, so I'm just going to bring them down. Haven't touched it, bring it down. Haven't touched it, bring it down. Repeat the process all over again. Take the first term on the outside. See how many times it goes into this first term. So x times what gives me negative 3x squared. That's something that we're missing is negative 3x. Put that at the top. And we're going to multiply. Negative 3x times x is negative 3x squared. Negative 3x times 3 is negative 9x. Draw the line. Subtract. Negative 3x squared minus negative 3x squared goes away. Negative 4x minus negative 5 minus negative 9x is 5x. I was jumping to the answer. And then we haven't touched the 15. Bring that down. So negative 3x squared minus negative 3x squared goes away. Negative 4x minus negative 9x is 5x. So I subtracted. Be careful with your signs. That's a negative minus a negative. So that's where I got the positive there. And this is the first one we've seen where we have to repeat the process 3 times. x times something gives me 5x. That something that we're missing is 5, so that goes up there at the top. And we're going to multiply. 5 times x is 5x. 5 times 3 is 15. Draw the line, subtract. 5x minus 5x goes away. 15 minus 15 cancels out. So x plus 3 is a factor. I do not have a remainder, and my quotient is 2x squared minus 3x plus 5. So our final answer is 2x squared minus 3x plus 5. Now let's get into this idea of a placeholder. I had briefly talked about it, but I want to show you a couple of examples. You want to make sure when you set up your long division that you start from the biggest exponent and you have a spot for every single exponent. For example, this problem started x to the third. Notice I have a number for x to the third, x squared, x to the first power, and then I have a regular number. So your exponents go 3, 2, 1 number. So you want to make sure all of your problems are set up in this way. If they don't have a number there, you're going to put a 0, and that 0 is called the placeholder. So example number 4. We're going to do 3a squared minus 7 divided by a plus 1. So we know that a plus 1 goes on the outside. When I set this problem up, I'm going to bring the 3a squared down. But hopefully you notice there's no a to the first power. So I'm going to put a placeholder for a to the first power. I just put 0 in there because we know 0 isn't going to affect my math. But it's giving us a placeholder so that in just a minute when I go through and multiply and subtract, I'll have like terms. So now it goes a squared, a to the first power, and then a number. So if we were missing two different things, I put 2 zeros for placeholders. If I was missing 3 different things, I put 3 zeros for a placeholder. So you have to make sure your answer, your problem is set up from the biggest exponent and has a place for every single thing all the way down to a number. So let's divide. A times what gives us 3a squared? That's 3a. 3a times a is 3a squared. 3a times 1 is 3a. Draw the line, subtract. 3a squared minus 3a squared cancels. 0 minus 3 is negative 3. Bring down the minus 7. Repeat the process again. A times what gives you negative 3a? So we're missing minus 3. Negative 3 times a is negative 3a. Negative 3 times 1 is negative 3. Draw the line, subtract. Negative 3a minus negative 3a goes away. Negative 7 minus 3 is negative 4. So this is not a factor, and my answer is 3a minus 3, and write your remainder over your divisor. So my remainder was negative 4. That's where I got the subtraction sign for. If it was a positive 4, I put plus 4, and then write your remainder over the divisor. Last one, and then you can go try some by yourself. I'm not going to go through this whole division problem, but I am going to set it up so that you can know what a placeholder is in case you still don't know. So notice this goes from a to the fourth to a squared. We are missing a to the third power. Your exponents have to go in order, and there has to be a number for every single thing. A to the fourth, a squared, a to the first, and then a number. So when I set this up, I'm going to bring down the a to the 4. I'm going to put a placeholder because I need something for a to the third power. And then I have my a squared, a to the first power, and then my regular number. So it goes a to the fourth, a to the third, a squared, a to the first power, and then I have a number. Now I have a place for every single thing. So it goes 4, 3, 2, one regular number. If I was missing an a to the first power, I put a placeholder of 0. If I was missing a number, I put a placeholder of 0. If I was missing a squared, I put a placeholder of 0. So it has to start from the biggest exponent, and you have to have a spot for every single thing. If you're missing something, then your placeholder is going to be 0.